Greetings, people of Earth. I'm Rick Harold. Thanks for watching my videos and listening to my podcasts. Today I'm talking about the future of AI or artificial intelligence and a little bit of what is it. Now, I think most people would recognize that artificial intelligence is supposed to be where the computer is either thinking or it's doing operations which normally a human being would do. So currently there's autonomous vehicles that are driving around using what people would perceive to be AI. There's algorithms out there which can recognize pictures. So you can see a dog and a cat. That's an example that's used over and over. Using algorithms from artificial intelligence. Alan Turing had the Turing test, which is one of a number of tests that people use in terms of saying if something is actually intelligent. And that's basically whether or not it can fool a human being, where the human being doesn't know who they're interacting with. Now, I'm not going to do a dissertation on this. There's plenty of other videos in the world for you to go learn more about it. I'm just kind of talking about it from our point of view and a little bit of a history about it. So the big thing right now, these days, is deep machine learning, all based, for the most part, on neural networks. Neural networks, for people who don't know, are basically algorithms which are modeled after human neurons, where you have a neuron that has a number of states coming out of it, a number of states coming into it, and it connects to other neurons. And based on inputs coming into a set of neurons, they propagate through, in some cases back and forth, to then send an output to a set of neurons at the end. These may be chained together, like in a human brain, and performing a certain particular function. So these aren't new. They've been around, and I don't know what the exact date is in the 50s, and I believe in the 40s there were some references to them. I remember first coming across them in the 80s during my master's degree, which was on natural language processing. I didn't work on them at all. I was doing parallel processing of a grammar ambiguity. But I saw them, and they looked really cool. But at the time, aside from being super busy, there wasn't anything practical to do. Geoffrey Hinton out of Toronto, who's considered kind of the godfather of this in this part of artificial intelligence, his focus has been these since the mid-'80s. It might be longer than that. And he's a big pusher of the concept today and new ideas going forward. He's the big name that you'll see. Now, there's plenty of other people in there, and I'm not trying to exclude anybody, but he's the de facto person you talk about when you talk about these neural networks. They've made a lot of progress recently, and the general public probably doesn't know all about it, but they'll see it indirectly. So driving cars, autonomous driving cars is one of them. Transcription is another one, where we're able to take audio, which is similar to video in a way from a data point of view, and use neural networks to predict what is the characters or the words being said, so that when the audio comes in from different people, it's able to do an accurate prediction. Anybody who's worked with transcription, starting back in I'm sure a long time ago, but I remember the Dragon program in the mid-'90s, which used a statistical model a little different, but conceptually similar. It's matching patterns. Know that the transcription's come a long way. Siri brought it to the forefront. We've used nuance servers for 8 years and experimented with those. Basically, it's a transcription server. And originally that was based off of Dragon through Nuance. There's a series of purchases that occurred. There's more to the story behind that, but so transcription's come a long way, and Google's been on the forefront of that. Amazon has it obviously with their products, and a lot of those are now starting to use neural networks, much like a lot of the image matching algorithms you'll see when Google or Amazon or Apple are taking your photos, and when you type the word cat in or dog or whatever, is able to find the picture because it was able to go through the picture using these algorithms. So now, is that artificial intelligence? Sure. A person normally would have to have done that. And I think I have a blog article, and I probably have something a little bit more at length I'll talk about. Artificial intelligence is a really generalized thing. if I took a calculator back to 1920, they'd think that had artificial intelligence in it because of all the things that you could do with the calculator. So you get the idea. A lot of times it's the perspective of the people using it at the time in terms of whether it's intelligent or artificial intelligence or not. So that's not trying to diminish anything. These recent milestones in terms of image recognition and transcription are awesome. We're benefiting from it with the work we're doing here with language and transcription, but also in terms of data prediction, it's really useful. So part of the reason why this is happening, so I've seen a lot of stuff through the years, in the 80s bust in terms of the artificial intelligence, and a lot of what's happening today is one, persistence, that these computer science and data science people have been persistent with algorithm creation over the years, even with garbage hardware. But also hardware's improved, right? So hardware improvement is big. So GPUs, where you could have multi-parallel processing going on, which was made for something else initially, gaming and video displays, now can be used to do parallel processing of this data at an immense scale. Specialized hardware, the TPUs that Google has, which is an extension of that really, to do neural networks more naturally. There are some other hardware out there, and there's actually 20 years ago, there was a company that had like a neural network board, and I remember looking at it. I don't remember how many neurons were on it. It was cool though, but the idea was that they're trying to put in hardware these structures for neural networks. So that's made a big difference. Memory's cheaper, memory's faster, CPUs are faster. There's a lot more software support that's out there to make this stuff happen. And of course now, cloud computing, which has Amazon, Microsoft, and Google providing not just hardware support where I don't have to have GPUs or TPUs like I want to buy those. I can just scale up however many I need for whatever short period of time on demand. And they have the software support, or other people have software support to provide abstractions around some of the complexities of the neural networks. And a lot of the process in terms of the neural networks, for people who don't know what they do, they're really estimators. I like to imagine when I try to explain to somebody, if you have a series of dots on a grid, X and Y graph, and a human being can look at that and say, oh, I see a line that could go through those, and that represents cat, let's say. And then there's another one which has a different set of dots, and they go a different direction, and that represents dog. Now, a human being can look at that and understand that. We can, of course, get line matching algorithms to match that. And if everything was that simple, of course, we'd be done. But that's kind of what's happening. Is you're matching these dots, this data, algorithmically to these graphs, these lines. Now, it's multidimensional, very multidimensional in what's happening in terms of determining what line fits it, and then optimizing that so that you're able to use existing hardware to do the matching using a bunch of training data. You can do it unsupervised as well, and then later to be able to get a new data point, picture, sound, whatever, and which curve is it going on in the multidimensional world. So the neural network represents this complex line graph, in layman's terms, that's able to recognize that as a cat or a particular kind of cat. So that has a lot of possibilities beyond just pictures and sound, or predicting data, stock market data, medical data. And it's accelerated the past, I'll say 7 years, to where it's as good as people in certain situations because there's enough data to do it, and certainly has the possibility of being infinitely better or supporting people, right? That's another thing that you do with a lot of this technology, like some of the automated autonomous cars that help you drive. So that's a lot of why now there's a lot of cool packages out there. We personally use TensorFlow. We've experimented with PyTorch. These are kind of modeling algorithms. There's Keras and FastAI.ai are more abstractions on top of the details. This pattern I've seen before in terms of, assembly language to C to C++ to higher end languages, and of course utilities and tools around it. abstractions to make it so that everybody can do this. So I'll include some links in the notes of the video. And anybody working in data science, computer science, interested in this kind of stuff, there's a number of great videos that talk in more detail about this. And it's something that you really need to know about because it's the basis of a great many things now. And it's only going to accelerate with the cloud computing and infinite scalability that's available, plus the new hardware support that's occurring. So that's it. Hope you liked the discussion. Please ask any questions you want and take it easy.